So, in the last lesson, we introduced this stimulated emission. Atoms have quantized energy levels. They can transition from higher energy state to a lower energy state. They do so by emitting a photon of energy h nu. They do that spontaneously, at random, following the rules of quantum mechanics. They can also absorb a suitable photon and go from a lower energy state to a higher energy state. But they can also be stimulated so that they jump down and emit a photon by sending to them a photon of suitable energy. If you have an ensemble of atoms, some will be jumping up, some will be jumping down, some will be steady. If you actually want most of them to emit photons, you need to stimulate this. You want most atoms to be in the higher energy state so that you can send them photons for them to jump down and emit more photons. Well, you have the ensemble, the gain medium emit light in the same frequency and phase. But if all atoms have emitted photons, they will be in the low energy state and they won't be able to emit again. There's where you need to supply energy, be it by applying an electric field through a battery due to the fact that atoms jump up without absorbing photons, or be it by injecting more light into the gain medium. Consider photons of wavelength of 650 nanometers red laser. Let's calculate this exponent and this ratio of stimulated versus spontaneous for a room temperature of 300 Kelvin. This gives a frequency of 4.6 times 10 to the 14 Hz. Gives a very small number. The ratio of stimulated states versus spontaneous states is really small. The radiation is dominated by spontaneous emission and will be incoherent light. We really need to get that ratio up. But there is something else here. The photons in the bath of the gain medium can stimulate the emission of photons, but they can also be absorbed without emission. That we also want to reduce so that photons are used mostly for stimulated emission. Let us calculate the ratio of stimulated emission versus absorption. From results from the previous lesson, the number of atoms in the lower energy state M that absorb a photon is dn sub nm. The number of atoms in the higher energy state that are stimulated to emit is dn sub mn stimulated. For completeness, the number of atoms in the higher energy state that decay spontaneously is the ratio of stimulated emission versus absorption is equal to the ratio of atoms in the higher energy state versus the number of atoms in the lower energy state. That is why we need more population in the high energy state than in the lower energy state. This is called population inversion, and it is the Leysin threshold. To get this population inversion, we need pumping into the gain medium. We need to supply the system with energy. May science be with you.